Hello guys, welcome all of you on behalf of Edureka, and I'm the person who will be conducting this webinar on for Kubernetes networking session. So let's start here. Let's start with Kubernetes. So what exactly is Kubernetes? Let's start with that. So we all are here for some Kubernetes action to see something with Kubernetes. Everyone is talking about Kubernetes nowadays. Kubernetes, containers, Docker, all these things, all these DevOps things are coming very like they're coming into quite into a large number in every environment, every now and then. What exactly this is, what containers are, what Kubernetes is. Let's talk about them a bit here, and then we will talk about the networking part, how exactly Kubernetes makes the networking for the pods easier, or how the pods or the containers run. So we'll see that. Okay. So let's talk about, before starting with the actual Kubernetes, let's talk a bit about our traditional world, how we do the things in the traditional IT world. Let's talk about those things. Okay. So let's suppose I have an application. I want to like put an application. I want to put a database. Okay. I want to put up a database application. I want to create up a server. What I normally do if I want to create up a database application, what we normally do, we normally create up a server first. Okay. In the older environments, this was a physical server, but nowadays, normally people don't use physical servers a lot. So we switch to the virtual machines. It can be a virtual machine or it can be a physical machine. Okay, so the first thing is that we require a server, be it a physical, be it a virtual. Okay, on that we install the operating system. Okay, we install the operating system, any operating system. For example, we are installing here Ubuntu or the Red Hat Linux. You can install anything Red Hat Linux you can install on this. Okay, after that we install our application. Okay, our application runs on this particular operating system. The application is a database. Now it can be any database like MySQL or MariaDB. Okay, and then this application is actually creating all the databases, storing all the data and everything, all the data, databases, tables, users, whatever you create is handled by this application. So this is what we normally do in our traditional IT. Okay, this is all about the traditional IT world that we still do. Still many companies work on this. Okay, they create servers for any application they want to host. Okay, but there are many drawbacks of this particular thing. The first drawback is the cost. The cost is the one of the biggest factor that increase on the over the period of time if you go with the servers. Cost in the terms like you need to procure the hardware cost, you need to put them in a data center. Okay, so that requires some power, that requires some kind of cooling. Okay, that requires some kind of manpower to just go on those data centers to visit all these things and take care of the things, take care of the servers. Okay, if there's any kind of maintenance, all these things you need to work on those things. Okay, so this was all about the traditional IT, which requires the cost and the creation time of a server, the creating of VM, installing operating system, installing any application is quite huge. Okay, you need to have for creating up a server normally it takes about 3 to 4 hours, and then installing application, creating databases. So everything is very time consuming. It may take up one day, a full 9 hours to create up one application server. Okay, so it's very time consuming, and the second important thing is cost. So because of these things, people started moving out of this traditional server kind of stuff. The other thing was that for hosting a single application, you need to have a server, you need to have a complete copy of the operating system. If you don't have the complete copy of the operating system, you cannot install your application. Okay, first of all, the OS is required. Although my main job is done with this application, I'm mainly focused with this application, I'm going to work with this, but first of all I need to have the operating system installed. I need to have a full-fledged copy of the operating systems. Okay, then only my application can go and run on this particular operating systems, else not. So people thought we are wasting enough resources as well. Okay, resources are not fully consumed. My operating system can take about 2 CPUs, can take about 4 GB of RAM. So if I have 100 application servers, those 100 application servers will each of them have their own operating system, will consume about 400 GB of RAM. If every operating system consumes at least 4 gig of RAM, and 2 CPUs, that will be 200 CPUs. That's a complete waste, because you don't require the operating system. You're mainly focused with the application. Okay, it can be any application, it can be a database, it can be a web server application, all these things. So people thought to move from here. They started thinking how we can use a single OS to host multiple applications. Okay, there the term of the containerization, the isolation, basically how we can isolate our applications, okay, which are running on a single operating system. How we can do such things in the real world, in the live world, how we can do such things. Like I have one application running and I want to run another application on the same server, but these two should not see each other. Okay, they can contact each other, but they should not see each other configuration files. How I can do that? Okay, for example, I want to run 𝐑𝐨𝐿 and Apache. Both of them are web server applications on the same server. I cannot do that without creating an isolation, without creating a boundary between them. Okay, that they cannot talk to each other. Okay, I need to create a boundary because both the applications require the server to expose port 80. Okay, Apache web servers or any kind of 𝐑𝐨𝐿 or HA proxy applications work on port number 80. So how I can have similar applications or even different applications created in a isolated environments on the same server? From there, the concept of this isolation comes up. And from there, the term called as containerization started. The term containerization started from here. How to containerize? Isolate means how to containerize. Now, what container is? Let's talk about that. Okay. Then we'll talk about Kubernetes. Let's talk about the containerization first. So what happens in a containerized world? We have a server. Okay. On this particular server, okay, now it can be a physical, it can be a virtual, any server is fine. On this server, we install the operating system. Okay, we install the operating system. After installing the operating system, what we do is normally we install the application directly. Okay, we install the second layer as the application layer, but we, instead of directly hosting the application on server, what we normally do is we install a containerization software. You call it as a containerization container runtime environment. We install a CRE application on top of an operating system. Now, what's the main purpose of this CRE is? The main purpose of any container runtime environment is to isolate, to create processes that are isolated in nature. Okay, means to create the containerized environment, to create the isolated environments for my applications. That is the main purpose of a container runtime environment is. There are many container runtime environments available in the market. We'll talk about them. Okay, but this CRE actually utilizes two features of the operating system. Okay, that is a C group, okay, and namespaces. Kernel C groups and kernel namespaces. There are two basic features present in any operating system kernel, that is C group and namespaces. So the container runtime environment, okay, utilizes these two features to create isolated environments for my applications. So by deploying this CRE, you can create containers on top of that. You can create a database container. Okay, you can create up a web server. Okay, you can create some kind of another application called as caching application, or that is any application for caching, for web server, for database. So multiple applications you are hosting on a single operating system, and none of them can see each other. They all of them are isolated. They are running within their own isolated environments. They are running within their own isolations. All the containers, these containers will have their own IP addresses. Let's suppose the container database has an IP address IP0. This will have a IP address 1, and this will have a IP address 2. Okay, so every container will have its own IP address, and these IP addresses, these containers will talk to each other using these IP addresses. Okay, they cannot see each other. Whatever data you will be sitting inside this container. And who is creating this isolation? This isolation is created by the container runtime environments. There are many popular container runtime environments available in the market. Okay, one of them is, we all know, Docker. Docker is one of the most popular container runtime environment available in the market. There are many others as well, like you have 𝐿𝑥𝑐 runtime environments, you have 𝐿𝑥D runtime environments, you have CRI-O runtime environments. There are many available in the market that provides you the isolation. Okay, that provides you the isolation for creating these environments, and that's what the world is moving towards. The reason why? Because on a single server, you're hosting multiple applications. Now if you talk about traditional IT, what you do, you create up a database server. Okay, you create up a caching server. Okay, you create up a web server. Okay, you create 3 servers, all 3 applications sitting on 3 different servers. Now the management, the administration of these become complex as and when you are increasing the number of servers. Okay, second thing, the power consumption will go high, the cooling will go high. Okay, the cost, you need to procure these hardwares. Okay, so it will go high. So that's why, how I can put all these 3 in a single server in an isolated environment, all of them running in an isolation through some container technology, through some container runtime environments. That is the main scope of any container runtime environment is. Okay, now as a standard container runtime, we have Docker. What we normally do in Docker, okay, now what we normally do in Docker is, we have the operating system, we have a machine. Okay, on top of this machine we install the Docker layer, we install our Docker software. Okay, on top of this we start creating up the containers. Okay, we start creating all the containers on top of this machine. Now each container has a single application hosted. Okay, and who enables us to create these containers? That is the Docker. Okay, that is the Docker. Now the biggest advantage of this is that you are utilizing the resource efficiently. On a single machine you have multiple application hosted. Okay, but there is a small drawback as well. Okay, what if this machine dies? What if this machine dies? Okay, then all the containers that are hosted on this machine will be dead. Okay, the containers cannot come up online, they will be dead. Okay, or let's talk about, I have one more machine. Okay, I have one more machine on which the operating system is installed and on which Docker is also installed, and the containers are also created here. Okay, now the challenge here is how these 2 containers can talk to each other, how they will talk to each other. Containers on the same VM can talk to each other, that's fine. Okay, that's the default networking. But how about the containers sitting on 2 different Docker machines? They cannot. That's one of the other drawback of using some standalone container runtime environments. We started with container runtimes because the cost of hardware was saved, the resources were properly utilized. Okay, the administration was a bit easier. Okay, because we just need to deal with 1 server. Otherwise, if you have an application hosted on 10 servers, it will be difficult for the administration. So we containerize everything. But the containerization itself, any containerization itself has some kind of drawback. The first drawback that you see, that you have multiple containers sitting on a Docker machine. This is a Docker host. Okay, this is a Docker host. Because I've installed Docker on this, you have multiple containers sitting on this. What if this machine crashes one day? Then what will happen? Okay, in such a scenario, all these containers will be lost. Your data is lost. So can you think to put such kind of environment in production? The straightforward answer is no. Testing wise, it is fine. For testing, for staging, okay, for non-production environments, it is fine. But for production, where you need the applications to be running 24/7, 24/7, you need the applications to be running. Okay, there you cannot use a standalone containerization environment. Okay, because if the host is lost, you're gone. Or let's suppose if one application is hosted in this Docker host, the other application in this Docker host, how they will communicate with each other? That's the bigger problem. That's one of the major problem that any containerization technology has. And for that, we require to overcome these problems. Okay, to overcome these problems, we require a orchestrator. We require a orchestrator to overcome such problems. Problems like if the host fails, containers will be lost. Okay, or the containers that are sitting onto two different machines, how they will communicate with each other, the networking, how it will be handled. That is the main drawback of using standalone Docker host or standalone container host. Any machine which hosts the container is called as a container host. If you are using Docker, it is called as a Docker host, Docker container host. Okay, so that's the drawback. We require an orchestrator to overcome such problems. Now, there are many orchestrators available in the market. One of them is Kubernetes, for which we all are here. Okay, Kubernetes is one of the orchestrator that overcomes such problems. How? I will tell you that. Another orchestrator that is available in the market is Docker Swarm. Another orchestrator. You have one more orchestrator, that is Apache Mesosphere. It is Apache Mesosphere. This is one of the another orchestrator. So three different orchestrator to overcome these problem. But the most widely used orchestrator is Kubernetes. This orchestrator is very widely accepted, okay, or very widely used in the real world, in the production world, or any testing world, non-production staging, anywhere. We use Kubernetes a lot because of certain reasons. Okay, Docker Swarm and Mesosphere are also being used, but I've normally used Docker Swarm sometimes, but Mesosphere even I have not worked. I've not seen any environment where Mesosphere is being used a lot. Okay, but yes, it is being used a lot in production as well. Docker Swarm and Docker Docker Swarm and Mesosphere, both of them. Okay, now we'll talk about orchestrator. What orchestrator are? What are the basic features of orchestrator and how it overcomes the problem? Okay, so in Docker, okay, in Docker, what we do, one of the participant has a question, what is difference between Docker and Docker Swarm? We'll talk about that. Don't worry about that. I've just started with orchestrator, so we'll talk about the difference. Okay, so in a standalone Docker, what we normally do, we have the operating system, we have the Docker installed here, and this creates a container. Okay, this is a standalone Docker. This is the standalone Docker. Docker is a technology, okay, that creates the container, that helps in creating the containers, okay, on a machine. Now, what Docker Swarm is, or what Kubernetes is. So if I talk about Docker Swarm first, so Docker Swarm is a cluster of such a host. A cluster, let's talk like this. Okay, I have multiple machines. I have multiple VM number 1, virtual machine number 2, and another machine 3. On all of them, we have the operating system installed. Okay, OS layer is present on all of them. Okay, and on top of this, Docker is also running. Okay, Docker is also running. Okay, so Docker is a technology that creates the container, and Docker Swarm is a technology that creates a cluster of hosts, that manages a cluster of hosts on which you create the containers. For example, now I can create a container on this. I can create a container on this. I can create a container on this. Okay, but these two containers cannot talk to each other as of now, because this is a standalone Docker host. This is a standalone Docker host. This is a standalone Docker host. These containers cannot talk to each other. So how this can be tackled? This can be tackled through an orchestrator. One of the orchestrators is Docker Swarm. In Docker Swarm, what Docker Swarm do actually, it manages all these three machines. It creates a cluster network between these three machines. It creates up a network between these three machines, and the container normally takes the IP address from this network. From these network, it take the IP address. Okay, now if the containers, all the three containers are taking up a IP address from the same network, they can definitely talk to each other, although they are sitting on different machines. This is what the main part of any orchestrator is. It creates, like any container technology is a standalone. You require orchestrator to handle a number of standalone hosts, and that orchestrator actually goes and creates up a cluster network across all the machines from where the container can take the IP addresses, from where the container can go and take the IP address. Okay, now they can talk to each other. Now, even if this machine fails, I have this container running here. If this machine fails, this container will definitely fail. Yes, we all know, but this is not standalone now. If the container fails here because this machine has failed, then what will happen? The container will be recreated on some other host. This container will be recreated on some other host and it will take the IP from the same network. That is what the orchestrator is for you. This is the main purpose of orchestrator. Okay, so the main purpose of orchestrator is to create a cluster for containers and to see the health of the containers. If any node is going offline, it can. This is a VM. Okay, the OS can crash, the motherboard can crash, or the CPU or the memory can go very high utilization. Okay, so definitely this container can go offline. But if it is going offline, now this is not standalone. This container will be recreated on some other machine. That is what the main purpose of any orchestrator is. Any orchestrator. Okay, so let's talk about Kubernetes here, which is for which we all are here. So how we do it in Kubernetes? Okay, so how we do it in Kubernetes? Okay, so in Kubernetes also, the basic architecture of Kubernetes is like it has a master node. Okay, in Kubernetes, let's talk about Kubernetes. Let me remove these. Okay, so in Kubernetes, we normally call it as 𝐶𝐶. Okay, Kubernetes in short form is also called as 𝐶𝐶. Okay, and why we call it as 𝐶𝐶? Because you see the first letter is K, we write K, and the last letter is S, we write S. Okay, and in between the first and the last letter, you have total 8 letters. Okay, you have total 8 letters between the first and the last. So that is why the reason we also call in short form, we also call it as 𝐶𝐶. That is short form for Kubernetes. So 𝐶𝐶 is a technology that was actually introduced by Google. It was introduced by Google. Okay, in the Google actually developed this technology in the year 2009. Okay, they started this and they were using this as a internal project. They were using this as an internal project, like it was not exposed to the outside world. Google itself used this Kubernetes as a project and they managed their containers, everything on their Kubernetes platforms, which was all internal. It was an internal project. Okay, later on in the year 2013, after 4 years down the line, when Kubernetes was quite established, it was stable, they donated. Okay, they donated Kubernetes to CNCF. What CNCF is? CNCF is Cloud Native Computing Foundation. Okay, this is CNCF. The project was donated to Kubernetes. The project Kubernetes was donated to CNCF in the year 2013. CNCF is Cloud Native Computing Foundation, which is a non-profitable organization that handles many open source projects. Open source projects means for which the code is available to the public. Okay, anyone can see the code. For example, Unix is an open source. You can just take the source code and you can create your own operating system, like Red Hat Linux, Ubuntu, CentOS. What all these are? These are all Unix flavors. Unix is an open source operating system. They take the code from there and they built their own operating system. They modified it as per their own choice and they built their own operating systems. Okay, so similar to that, Kubernetes is also open source. Okay, that was donated by Google, and in year 2013, since 2013, this is being present. This is being managed by CNCF, and developers across the world sits and contribute to Kubernetes. Even if you want to develop something, if you're a developer, okay, and this was developed actually in Go language. Okay, this is developed in Go language. Go stands for Google language. It stands for Google language. Okay, so Google actually used their own language to build Kubernetes, as Kubernetes is their own product. Okay, Google also maintains this, it also manages this. There's a big community in Google that manages Kubernetes. Even across the world, even if you are, if I am a developer, I know there's a bug in Kubernetes, I can fix it, I can send the code to the community will approve it and put that fix in that code, in the Kubernetes code, if I know it, if I know it's a bug. So even I can contribute to Kubernetes. It's completely open source now. Okay, nobody owns it, there's no licensing required. No licensing required, nothing required. You don't require a vendor lock-in, like you need to go to a vendor and get the things done. No, it is not like that. Okay, it's all absolutely free. Okay, the only thing is that it is managed by CNCF. However, the testing and the developers, all of them sit across the world. It's a very big community, very fastest growing community, and a very big community in the like the GitHub. If you see the GitHub project, there are around 7 to 10 million people who are actually contributing to this project. Okay, a very huge community. Okay, so we'll talk about Kubernetes here. So Kubernetes, we are talking about the architecture a bit. So Kubernetes basically constitutes of two type of nodes. One is a master node, okay, master node and worker. Okay, every technology works, whichever is working in a cluster, always have a master slave architecture. Okay, if you have worked with any like databases, also with databases you have master slave architecture. With Jenkins, if you work with Jenkins, it also has a master worker node architecture. Okay, if you work with Docker Swarm also has master worker architecture. Kubernetes also has a master worker. Master node is the node which sends the instruction to the worker to perform some task. Okay, master node is the node which receives the user request and sends the instruction to the worker to perform something. That's the main job of a master is. And worker is the node that actually performs the task. So master node always, in any master slave architecture, master node always receives the input from the user. Okay, the API of the application API sits on always on the master. API is actually for the user interaction. So Kubernetes API also sits on the master node. Okay, and that accepts the user request for creating containers, for creating pods. Okay, and after that the master sends the instruction to the worker, and worker actually go and create the pods or the containers. So how does it look like? Okay, so how does it look like? So you have a master node, okay, a master VM on which you install Kubernetes components. A master VM, it is normally a Linux machine, any Linux, CentOS, Red Hat Linux, Ubuntu, any kind of Linux operating system is fine. Okay, normally we don't use Windows with Kubernetes. I think maybe it is not compatible. I've not seen such with Kubernetes, like anyone using Kubernetes on top of Windows. You can use Docker desktop on Windows, but with Kubernetes, I think it's the Linux is the way forward to work with Kubernetes. Okay, so we have a master machine. On that master machine, so we have a master VM, and on that master VM, we have the API of the Kubernetes sitting. The main purpose of this API is that it receives the input from the user. Any input is received, like I want to create up a container. Okay, so I will be sending it to the API, the Kubernetes API that runs on the master machine. Okay, now you have multiple other machines as well. You have multiple worker nodes. Okay, I have a worker node number 1, I have a worker node number 2, some architecture like this. Okay, Now, once you're sending an input to the master API, to the Kubernetes API to create up a pod, to create up a container. Actually, in Kubernetes, we don't call it as a container. We call it as a pod. A container is equal to a pod here. Okay, what pod is, we'll talk about that. Okay, so what we do is we send an input to the API for creating up a container. In Kubernetes, we call it as pod. So we will be creating pod here. API will send the request to the respective worker. Okay, the worker will actually be creating the pod here. Inside the pod, you have the container running. So what we have inside the pod? Inside the pod, we have the containers, and in the container, we run the application in Kubernetes. So we need to install Kubernetes components on any machine. On any of these machines, we install the Kubernetes components. Okay, you can have as many masters, as many workers as you want, but the main thing is that these all are running in a cluster. Okay, so what the main purpose is, let's suppose I have 3 machines here in a cluster, and I am creating up a container in Kubernetes. I want to create some container in Kubernetes. Okay, so what I will do here is I have some worker nodes, worker 1, worker 2, worker 3, on which Kubernetes is running, and I have a master node. Okay, I have a master machine. So all these machines are running in a cluster. All these machines run up in a cluster, which is also called as the pod network. This network is also called as the pod network, or you also call it as CNI, container networking interface. Any terminology is fine. The cluster network, the pod network, or the CNI, container networking interface. So on these nodes, what we normally do is we first of all have a cluster running. Whenever you install Kubernetes, whenever you have Kubernetes up and running on the machines, you install the components. Like I require some Kubernetes packages on this. Some Kubernetes packages will be installed on all the machines. After those packages are installed, I will create the cluster. Okay, but before creating the cluster, this particular thing is required. We require the cluster network, because without this, Kubernetes is not going to work, or any contain or any orchestrator is not going to work without the cluster network. This is most important thing in any orchestrator. Normally we call it as orchestrator. Orchestrator means with somebody that orchestrates, somebody that manages something. But the main purpose of any orchestrator is this, the network, the cluster network, because now you will start creating the pods, and the pods will start picking the IP address from this network. You create as many pods. You create P1 pod, P2 pod. It will take the IP from this P3. It will take here P4 pod. Okay, it will take the IP address from this. It will start taking the IP addresses from these network. Okay, now in such a scenario, if any of the pod fails, if let's suppose this pod fails, okay, what will happen? The orchestrator is very smart enough. The orchestrator is smart enough. It sees that the pod has failed. Now it can be because of any reason. Maybe this worker node is offline. If this node is offline, definitely this pod will die. Okay, this pod will die because this is running on this machine, and this machine is a VM, is a virtual machine. Normally we don't use physical servers nowadays, so that's why we use virtual machines a lot. So this is a VM. Okay, and if this VM fails, the pod will definitely die. Then what will happen? Okay, orchestrator is smart enough to move this pod to some other node. The P3 pod will be moved here. The orchestrator is smart enough. Okay, along with that, this pod P2 can communicate with P3 even. Why? Because it is taking the IP from the same network. That is what the main purpose of any orchestrator is, to create a cluster for the containers. Any orchestrator you talk, okay, any orchestrator. We are here for Kubernetes. Kubernetes also does the same thing. It creates a network between the machines, but that network is for the pods that are created on the machines. From those machines, it will take the IP address and they can start communicating. Now, these two cannot communicate with each other? These nodes are not in cluster, guys. Okay, one important thing to understand: the worker 1 and worker 2 are not in cluster. These pods are in cluster. Okay, these pods are taking the IP address from the same cluster, from this network. Okay, now even if one of the pod will die, doesn't matter. Kubernetes know if the worker node is offline, if the pod die, he will recreate the pod itself himself. Okay, the pod will be recreated automatically. Okay, and once the pod is recreated automatically, it will get the IP back from the same network. Okay, and they will start talking to each other again. Although the IP address can change, but it will be in the same range, because the range of the network remains same that has been deployed. That is what the main purpose of any orchestrator is. Kubernetes networking is mainly focusing upon this part only, creating a cluster for the containers. Okay, so let's see, guys, how we create a pods on the cluster. Okay, let's do a small demo how we create up a pods. I will be using some public clouds. I will be using Google Cloud Platform to create up a cluster, and let's see how we create up the pods, how we see the pods, all these things. Okay, so let's focus on that part. So let's see a small demo, a quick demo here, how we do the things. Okay, so we have master nodes, we have the worker nodes. Okay, let's see the master worker components here. So let me go on my shell. I am on my cloud platform. This is my GCP machine. Okay, so this is my Google Cloud here. Okay, from where I have just taken up a cloud shell. Okay, this is my cloud shell from where. Okay, I already have a cluster running. Just before the start of the class, I created one cluster. So how I opened this, I'm just showing you that. Okay, what I did here is I just click on the top this button. Okay, why I use GCP? Okay, because GCP is actually, I'm using GCP from last 7-8 months now, and I find it quite user friendly, and I've learned a bit of GCP as well. So that's why I use GCP. But it's your choice. You can use any cloud platform to create virtual machines, to create you can do it on AWS, you can do it on Azure. If you are using DigitalOcean, you can use DigitalOcean. You can use any of the public clouds that you can go with, okay, to create up the clusters. I will be using GCP. Also, one reason for GCP is it is free for 3 months. Okay, it is absolutely free. For the first 3 months on GCP are totally free. If you are a new user, so 3 months, the first 3 months are absolutely free. You are not charged. Actually, it's not completely free, but you get a $300 credit. Okay, you get a credit for $300. Okay, and I think that is quite enough for 3 months. Okay, for practicing GCP or for the practicing Kubernetes on GCP, $300 for 3 months is quite good. No other cloud provider gives you that. Okay, other cloud providers, like you have Azure is free for 1 month. AWS is, I think, free for some 1 year, but it gives you only minimal resources. Like you can just create a machine with 1 GB of RAM, okay, with 1 CPU. Okay, however, in GCP you can create machines as big as 8 CPU. It gives you a limit up to 8 CPUs. Along with that, around 1 terabyte of RAM is also it gives you in the free tier in the first 3 months as a free trial. Okay, so that's why I normally use GCP, and I always ask most of the participants to start using GCP as it is free for 3 months, so you can learn a lot. You can, means 3 months are good time to learn Kubernetes. Okay, so I've opened up my cloud shell here. This is my cloud shell, and on my cloud shell, if you can see, I've just set up the region zone. I'm into the project that I'm working here, my first project. This is my project. So I'm working into this project on GCP, and I've just created up a cluster. I just issued this command to create up a cluster. Okay, �:cloud container clusters create. I give the name of the cluster, hello cluster, and how many nodes I want to have, how many nodes of master worker I want to have. So I just want to have a 2-node cluster. Okay, that is what I have defined here, a 2-node cluster. That is what I want to run. So right now the session is disrupted. Let me reconnect to this. Okay, the cluster is all created, so we can just see that. So how we can see a cluster is created? Okay, we need to interact with Kubernetes. So how I can interact with any Kubernetes cluster, how I can interact with this? There's a command line utility for interacting with any Kubernetes cluster. The command line utility is 𝐶TL. 𝐶TL is the command line utility for interacting with the Kubernetes cluster. Okay, so let's see to interact with the cluster. Okay, so let me run this 𝐶TL. Any Kubernetes commands always start with this 𝐶TL. Any Kubernetes, whenever you are interacting with Kubernetes, the command will always be starting with 𝐶TL. 𝐶TL, or you also call it as 𝐶𝐞-𝐻. Okay, if you're from North American region, so in North America, most of the people also call it as 𝐶𝐞-𝐻. In European regions, in India, in Asia Pacific, we normally call it as 𝐶TL. So one and the same thing. So all the Kubernetes commands start with this, and this is the command line utility. Okay, Kubernetes command line utility to interact with the Kubernetes clusters, to send any request to the Kubernetes API that runs on the master. Okay, so 𝐶TL get the nodes. If you just simply run this command, you will see that how many nodes I am running Kubernetes onto. So this will give me an output. See, I have a 2-node cluster, okay, which is running from last 54 minutes. Okay, I have a 2-node cluster. Both of them are in ready state. You can also see that these machines are created in the backend of my GCP platform. If you just go here and if I just show you these machines, okay, just go on the compute side. Okay, these machines are running there. Just a minute, let it come up. Yeah, you can see these two machines are running up here. Okay, the first machine, GKE hello cluster default pool this, and GKE hello cluster ending with W72T. W72T and ℏRGQ, these two machines are running. See, these are 2 nodes on which Kubernetes is installed. Okay, and Google does it. I just need to run a command, �:cloud container clusters create. Okay, I just need to run that particular command. What command did I run? This command I ran to create the cluster. Automatically Google will go and create the nodes for me. Okay, I don't need to, because this is all automated process. You can also do it in on-prem. There's a different way how we deploy it in on-premises. Okay, if you are doing a Kubernetes on-prem, you're not using any public cloud vendors, it's fine, you can do it on-prem, but for that it's altogether a different approach how we install that. And for that it's actually a very quite long approach. Okay, if you want to search it, you can simply search 𝐶𝐫𝐴DM deployment. Okay, just search this on Kubernetes creating a cluster with 𝐶𝐫𝐴DM. This will walk you through how you create a cluster on-prem, creating a cluster with 𝐶𝐫𝐴DM. So a cluster is running. Now let me start creating some pods. So how will I create the pods here? I will run a simple command, kubectl run, and after that I need to give the pod name. Let's suppose I want to give my first pod. Okay, pod is actually a container which runs a container in Kubernetes. Okay, and what image of the application I want to run inside this? So I need to give the image. Okay, image means the application that will be running. For example, for installing an operating system, I require the ISO image. Okay, for installing any operating system on a machine, what I require? A ISO image. Okay, similar to that, for creating a container, what I require? I require the container image. I require the image of the container. Okay, without this I cannot create a container. So let's use an image, a very small image, and one of them is 𝐿𝐺𝐼NX. 𝐿𝐺𝐼NX is a web server application that I'm picking. So if you want to check from where I picked the image, so you can just go on this hub.docker.com. So from this website, actually the image will be pulled. If I search here for 𝐿𝐺𝐼NX, you can see it up here. This 𝐿𝐺𝐼NX official image, this image will be pulled, okay, when I am starting the container. So this is the command to pull the image, but when I'm in the Kubernetes also using the same, okay, this is going to pull the image from here only, from Docker Hub. Okay, so let's see that. So I just run this command, kubectl run, the name of the pod, my first pod, and the image minus image is equal to 𝐿𝐺𝐼NX, and this should create the pod for me. kubectl pod created. Let's see the pod. kubectl get pod. Okay, see, it is saying container creating. So what happens in Kubernetes is that you have the pod, inside the pod you have the container. Okay, this is the name of the pod. Okay, however, I've not specified the name of the container, so by default the name of the pod and name of the container will be the same. They will be same. Okay, both pod and container name will be same, but it is by default. If you want to change the container name, there's a way. We need to create up a YAML file, we need to create up a config file for that, and I can change the container name as well. Okay, but let's see if it is created or not. Okay, let's see if the pod is running or not. kubectl get pod. You can give a short form kubectl get po, or the full form kubectl get pod, one and the same thing. Okay, this will give me the output. Yes, now it is running, you can see. And let's see on which node it is running. Okay, minus output wide. Okay, out of these two nodes, on one of the nodes the pod should be running. I told you the pods run on the worker nodes, so on one of these nodes the pod should be absolutely running. Let's see that. And yes, you see the first pod is running on the node W72T. It is running on this node. It is running on this particular node W72T. See, the pod is running on this node. Now let's just do a describe on the simple pod. How we do it up? kubectl describe the pod, and I give the pod name. Okay, I give the pod name. Let's see some events on this. Okay, I'm just describing the pod. I'm running a describe command on the pod. Okay, so if you run this command, you see some describe the pod. You see this pod here, my first pod, kubectl describe pod. This, just a minute, let me do this. Yeah, now you see something here. See, the pod is running, my first pod. Okay, and inside the pod you have a container. This is the container. The IP address is always assigned to the pods. In such a scenario in Kubernetes, like in Docker what we do, in Docker we create the container, and container have the IP addresses. Okay, but in Kubernetes what we do is we create the pods. Inside the pod we have the container, and the IP addresses are assigned to the pod. To these pods IP addresses are assigned. IP addresses are never assigned to the containers. Okay, you see it up here. This is the pod. Okay, this is the IP address. Okay, and this is the container that is running. See, the container image is 𝐂𝐽𝐼nx. Image is, like, one of the participants asked this question, what is image? So image is, like, for example, if I want to install an operating system on a VM, what I need to do? I require the image of the operating system. How do I install an operating system on a VM? You require the ISO image. You require the ISO image for installing the operating system. Same thing for creating up a container. What I require? I require the image of the container. The image is actually a package that actually contains the application. Once you start executing, once this image goes into the running form, it creates the container. Okay, like ISO images, like for example I want to install Windows. Okay, so for Windows you need to have a bootable disk on which the ISO is there. Okay, or if you're installing Linux, for that you require ISO, the image. Okay, which has all the packages for the operating system. Same thing, I'm installing 𝐑𝐴𝐼nx, so I require the 𝐑𝐴𝐼nx image that contains the code of that application. The application code, application package is called as the image, and once you execute that image, it creates the container. So this is the container that I have. Now in a pod I have a container. Okay, but in a pod Kubernetes can allow you to have multiple containers as well. You can have multiple container pod as well. I can also create this if you want to do. Okay, for that I need to go through a configuration file. That is not possible to, many of the things are not possible to the command line. I can show you a small configuration file, okay, before I create the pod. Okay, let me do that here. So let me just go to my contents. Okay, yeah, this file. So you can see what I am doing here is, sorry, I'm executing this particular YAML file. So either way to create a pod is through the command. Okay, I can use a CLI. Okay, like I executed this command to create up a pod, but this pod will never allow me to create multiple containers inside a pod. Okay, I cannot create multi containers inside the pod. Okay, but in a pod, if I want to have two containers, how I do is I create a YAML file. Okay, so in this file, I'm telling that I want to create up a pod. The pod is a part of the V1 group, V1 API of Kubernetes. So I'm giving the version here. Okay, in the metadata, I'm giving the name of the pod. Okay, and in the pod, I want two containers. First container, second container, two containers. The first container is running 𝐂𝐿𝐿. The second container is running RabbitMQ. RabbitMQ is a messaging application. It's a RPC protocol, like RPC queuing messaging services we have. So RabbitMQ is like a messaging service. Okay, and 𝐂𝐿𝐿 is a web server. Okay, so I will just go and execute this YAML file. How will I go and execute this YAML file? kubectl create -f, and I simply give multi-container dot. Let me clear up my screen. Yeah, multi-container.yaml. Okay, so this will create a pod with two containers. We'll see that. Okay, so kubectl get the pod. Let's see it. And now here you see multi-container pod. It is showing 0 by 2. 0 by 2 means there are two containers out of which 0 are running right now, because it is container creating. That's why it is showing 0. It will take some time. Let's see it again. And now you see 2 by 2. 2 by 2 means this pod have two containers, and out of which both of them are running. 2 by 2 means total two containers, and two out of two are running. Okay, that is what it means. So I have a pod with multi containers, 2 by 2. Okay, if you want to just do a describe, let's do a describe. Describe the pod and give the pod name. Okay, let me just do this. Yeah, now I'm just running a describe command. So you see the describe here. Okay, see, this is the pod. The pod has an IP address. This is the IP address of the pod. Okay, now in the pod you have two containers. First container, which is 𝐂𝐿𝐿. Second container, which is RabbitMQ. So I can also execute multiple containers within the pods, and these pods run on the nodes, on the worker nodes. Okay, because pod requires some CPU, pod requires some memory, so it always and always will be running on some node. If you want to check on which node it is running, I can show you. I just need to run the command kubectl get pod -output wide to check which node the pod is running. But here you can see the pod having two containers. First container, second container. Second container is running RabbitMQ. First container is running 𝐂𝐿𝐿. So if you want to check on which node, kubectl get pod -output wide. I think kubectl get pod -output wide. Yeah, you can see this multi-container pod is running on node ℏ𝐺𝐞. I have two node cluster. So this is the node on which this pod is running, and on this node W72T, my first pod is running. Okay, so guys, this is how we create pods on Kubernetes. So this was a small demo about Kubernetes, what Kubernetes is, and why we use Kubernetes is because Kubernetes is the first orchestrator that was available in the market. Okay, it was the first orchestrator, and anything that is first, okay, anything that is first will always have a greater market share. Okay, it always has a greater market share. For example, AWS. AWS came in the market in the year 2006 or 7 somewhere, and you can see the market of AWS versus Azure and GCP. AWS has 60% of the market share. Okay, Azure has another 10, 20, 30%, 10, 20%. GCP has another 10 to 15%. Somewhat it is DigitalOcean. But many of them are still working on the private clouds like OpenStack. Okay, so whichever technology comes first has a bigger market share, and that is why the reason people have adopted Kubernetes a lot. And Kubernetes gives you many features. The community is very wide. The features that Kubernetes offer you are many. Okay, so that is why Kubernetes plays an important role in all the environments that you work in: production, in staging, in non-production, or any organization in the DevOps world. Kubernetes has a very important role to play. Okay, so guys, that is it all from my side. Have a great time ahead. Thank you. Bye-bye.